Okay, so you're starting from, what did it say? Butanoic acid? Butanoic acid. So, 10. So this is your starting reagent, right? Or is that what you're synthesizing? It doesn't really matter. I think, yeah, this is what you're starting with. And you're making the alcohol, making the bromide, making the alkene, the aldehyde, the nitrile, or the amine. Okay? Okay. All right, good. I'm going to go on mute and pause while you guys work on that. And then just let me know in the chat box when you guys are ready. Hopefully the others had a chance to get through most of them. So let me first go to the alcohol. Because from the alcohol, you can get C and E and B. You can actually get to B, C, and E all from the alcohol. And then D and F you can get from the alkyl halide. So you can kind of... Let's do that. So to get to the alcohol, you just reduce it. And you have to use LAH in this case. If you did sodium borohydride, that is a reducing agent, but that doesn't reduce carboxylic acids. Okay? So you gotta use LAH. Alright, to get to the aldehyde, let's just go there first. To get to the aldehyde, so that's B. I'm not going to draw it out just to save time. You can either add PCC or PI from the alcohol. To get to the alkyl halide, you either add HBr or you can add PBr3. To get to the double bond, I'll just type it here, you just add acid and heat. Alright, I think it was sulfuric acid. Isn't that what the book uses? I think sulfuric acid. Heat. So that's a dehydration reaction. You could also make it from the alkyl halide. Let me actually write, so put the alkyl halide down here. So I'll put PBr3. You can also make the double bond from the alkyl halide by tert butoxide and heat, just the E2 elimination. All right, and then the nitrile and the amine all come from the alkyl halide. You can do it from the acid chloride, or from the acid too, the amine. I'll talk about that. But for the nitrile, just add like sodium cyanide, or if you want to write it as just like Cn minus, that's fine. That's just a regular SN2 reaction to get that nitrile. And then the amine, same thing. You can just add NH2 minus. That's an SN2. The other way is you can make this into an amide. You can make the carboxylic acid. So if you take the carboxylic acid, what I would do is make it into the acid chloride first, SOCl2. Acid chloride, then add ammonia to make the amide, and then take the amide and add LAH to it. And you get the amine. I'm not sure how the answer book does it, but either one of these ways will work. If you guys have the answer book, if you want to just quickly let me know as far as that amine, if they do the SN2 or if they do the amide. It's not important. Either way is fine. All right, any questions? Yes, Anna. If you want to go off your mic, that'll be easier.
On the bottom right section where you had the double bond O, NH2, and then you did LAH to it?
Yes.
Where did your OH go?
The OH?
For your final product? Yeah, because isn't when you're reducing it down,
or the carbonyl? So,
yeah.
So are you talking about the formation of the acid chloride or the LAH?
the LAH right there.
Yeah, so the carbonyl, it forms water eventually. Okay. Yeah. So it's kind of like the same thing like this reaction here. Like if you think about it, the LAH in this, you basically are removing the carbonyl, right? Like my OH is staying and the carbonyl is going. That's not how the mechanism works, but that's basically how it's doing it. So it's basically I'm getting rid of the carbonyl and everything else is staying. That's kind of the same thing here. I'm getting rid of that carbonyl and everything else is staying. That's kind of how you can look at it. Yep, no problem. All right, good. Any other questions on these? All right, let's just keep going. Let's do ibuprofen. Let's synthesize ibuprofen. Never be without ibuprofen. I did hear, however, I don't know if you guys heard this. This was a while ago, like 2 or 3 weeks ago, which seems like an eternity ago. But I heard that with the if you do get the coronavirus, that ibuprofen is actually not what you want to use. You want to use Tylenol, acetaminophen. They're saying that ibuprofen is not working as well. Yeah, you heard that too, Anna? Yeah, I don't know. I mean, ibuprofen works way better on me for everything, pain-killing, everything. But I guess in this case, you don't want to use it. You want to use acetaminophen more than ibuprofen. I'm not quite sure why that came out, or if that's even still, at that point, like 2 weeks ago, every day something new was coming out, and I think people something about I heard it was something because the acetaminophen, ibuprofen is also an anti-inflammatory. I was hearing it was somehow that anti-inflammatory effect is that you don't really want the anti-inflammatory. Is the thing I was hearing about it. I don't know if it was something else. Yeah, you saw that too. Which I thought maybe you would, because when you get it, your lungs inflame and they fill up with fluid, and in order to treat that, you actually do an anti-inflammatory in order to get rid of that. So that's why I thought it was weird. Why would you want to get rid of the anti-inflammatory where you want it? It's a myth. My mom was talking to the doctor. Oh, really? Okay. All right. I believe that more, Ashley, just because there's so much stuff that's coming out. So, okay. We've got both anyways, just in case. All right. Anyways, go ahead and synthesize ibuprofen. Through the ways, and if there's another way that you guys have done and I didn't do it, please let me know so we can look at it and we can just show other people all the ways of doing it. So instead of writing this whole thing over and over again, I'm just going to write it as pH. All right, so I'll just write this whole thing as pH. All right, so the first part, well, I guess I have to show you the first part. After this, I'll do pH. All right, the first thing is you have to put on a group here. Okay, I got to put something on. There are basically two possible ways to do it. You can either put a bromine on there and then start making Grignards. I'll do that first. So Br2 and then add FeBr3. And basically, I'll just write the aromatic ring. You get a bromine there. All right. And then make it into a Grignard. And then you can add it to a lot of different things, but let's just add it to the methylaldehyde, and you will get this alcohol. All right. Another way of making that alcohol, let me just show you another possible way, is to take this compound and do the Friedel-Crafts acylation, put on this group, and AlCl3. Make this, and then reduce it in order to make that NaBH4. So there are two different ways, but you basically have to get like to this aldehyde. I'm sorry, to this alcohol. That's kind of where you have to get to. And there are two ways. Either make it into a Grignard and add it to an aldehyde, or just do the Friedel-Crafts acylation. And make it into the alcohol. Okay? And then from there, really I'd say, again, there's a few ways you can make it a Grignard. But first thing is you have to turn it, so you can use SOCO2 or PBr3 or HCl or HBr, whatever you want in order to turn that into a alkyl halide. So let's just make it a chlorine. Then there's two things you can do. The first thing I thought of is adding the cyanide to it, the nitrile, and then adding the base and the acid to hydrolyze it into a carboxylic acid. So first step was sodium hydroxide. Second step is adding acid, and you can make it into the carboxylic acid. Sorry about the room there. That was one way of doing it. The other way is, let's see if we can get room up here. If you have the, I'll just put pH here. You have the chlorine, turn it into a Grignard. This is probably going to be more steps this way. Add it to formaldehyde, and then second step is adding H+. You get an alcohol, and then oxidize it up. So like CrO3 and acid. That's another way of doing it. Okay. Anybody have something different? If so, let me know. If you want to go off the mic and tell me, that's totally fine. Can I see the bottom? Yep, sure. Sorry about that. Is that good, Jacob? Do you want me to show the top again, or are you good? Okay, good. Okay. Any questions? I want you to synthesize this compound, but I want you to start with, let me think about it a little bit. What do I want you to start with? I want you to start with, I want you to use this. Right? You can use anything else in the reaction, but you have to somehow start with this and use this. Let me think about it for a second. Yeah, I think that looks good. Oh yeah. Oh yeah. Good. Perfect. That's perfect. Okay. So you have to use this, and you got to synthesize this. So start here. Obviously, it's going to be a series of steps, quite a few steps. All right. It could be anywhere from like 3 to 4 steps to 6 to 8, just all depending on the route that you plan on taking with it. Okay. So I'll let you guys work on that. Okay. All right. I'm going to go on mute. All right, let's get started here. We have time for stuff. Okay, so like I was saying, these 3 carbons are these 3 carbons right here. So I'm trying to attach these 3. So if you go backwards, all right, You're going to form an ester. So let's see. 1, 2, 3, 4, 5. 2, 3, 4. 1, 2, 3, 4, 5. So that carboxylic acid plus that alcohol in the presence of acid. So I'm doing the Fischer esterification right here. 1, 2, 3, 4. Yep. Okay. So I'm trying to synthesize this carboxylic acid. All right. Now, if you made this the acid chloride and did it, that's fine. If you made it the anhydride, either way is fine. So I'm trying to make this acid, so I have 3 carbons here that I'm trying to add on to here. Okay. You can't add 3 carbons at once. All right, or at least we haven't learned how to do that. Especially since, I mean, you could, but you want the group, in order to be on this carbon. If I were to take this and add a Grignard, a 3-carbon Grignard to it, I would have the oxygen hanging off of this carbon. So I have to get the carboxylic acid at the end of the chain. All right? And notice I'm adding carbon. So, we learned that you can make a carboxylic acid from a nitrile. So one route I was thinking was if I were to get this compound, so have like a Cl here, or I'm sorry, have a nitrile here, and then add the sodium hydroxide and the HCl. So this is first step, that's the second step. Right? So if I were to get this nitrile on, I can hydrolyze it and make it into the carboxylic acid. So to get the nitrile, we learned that you need to have an alkyl halide here. And add Cn minus. So notice now I only have 2 carbons I have to worry about. I only got 2. Right? Because I have 3 carbons I got to worry about. I have to worry about this carbon, and this carbon. Carbon 3 is the one that has the acid. So that's the one I have nitrile on and hydrolyze it to get the carboxylic acid. So then I have 2 more carbons, but notice the chlorine is at the end, again, at the chain. Okay? So in order to get that, okay, in order to get a chlorine, if I had a double bond there, okay, what I could do is I can turn into the alcohol. I can put an alcohol group here eventually with anti-Markovnikov and all that stuff. However, this is impossible like to make. If you're trying to go a double bond route, you can't do it, because if you were trying to put this group on, I would have an OH or something right here, and if you eliminate it, it would go Markovnikov. So if you're trying to go through the double bond route, you can't do it. You have to put on each carbon individually. So in order to make this chloride, you would have to, so it's basically, there is no easy way of doing this. You just have to do 1 carbon at a time. All right. So then in order to make this alcohol, that would be from a Grignard. So Mg, nope. Add it to an aldehyde, add acid. So notice here I have the carbon 1. This is the carbon 2 on 2 I'm adding onto it. And then in order to make this Grignard, it has to come from the alkyl halide, which then comes again from the alcohol, which comes from another Grignard. So basically I'm doing this Grignard twice in order to get to it. MgCl. Which then eventually would come from here. The first step would be to turn into a chlorine, and then the second step would be to add magnesium to make it the Grignard. All right. This had a lot of steps to it. Do you guys get close? Do you guys have something different? Do you want me to maybe talk about what you had, and if it was another way? I did something different. All right, Anna, what do you do? I don't know if it's right. Once you go off, yeah.
I probably messed up somewhere.
Okay.
But I did CrO3 to begin with to make a ketone.
So off of here.
Yeah.
Okay. I'll tell you what. Let me. I want to try to get a clean page here. Let's just do this. Oh, I don't do that. Okay. I'll just write it. I'll do it in green. Okay, so here,
I'm going through critically as we go.
so you made it. So you made it into a ketone. Okay.
Yeah, and then I did a Grignard with the rest of the CH2, CH2, C double bond O, OCH2, CH3, like that end chunk.
So a CH2, CH2, and then a double bond O Grignard to it. Okay. So you would have that compound, right?
Yeah, but then I also had like the ending section with the OCH2, CH3 at the end.
So you
Like
have the
I
carbonyl.
basically did that whole
So, okay.
chunk. Does that make sense?
So you had this here, right?
Yeah.
Is that what you're saying? Okay.
Okay.
So you can't make a Grignard on the ester because it would react with itself immediately. Because,
oh, really?
Yeah, because Grignards react on a carbonyl. So if you had a Grignard here, it would immediately react upon itself or on another one.
Oh, okay.
All right. But what did you do with this OH? How did you get rid of this?
Yeah, so then I did H2SO4 and I made it become a double bond, and then I hydrated. I did H2 excess.
And you hydrogenated it. Okay. Yeah, I mean, that would work if you were able, in order to make that Grignard, which that would not. So if you make a Grignard, remember, Grignards react with carbonyl compounds. They also react with very acidic protons. So you can't have either one of these on the molecule that you're making a Grignard on. Okay? Does that make sense? I thought you were going this route. Because it was actually, I didn't think about this, but then I couldn't think about. So I thought you were going where you had a double bond here, which that would, and then did an anti. Yeah, let's let's pretend we did that. Well, yeah, I am, but it's still a trap. That's why. So if we did that. Let me think. If we did that, you can put the OH here by anti-Markovnikov, so a BH3 and the H2O2. So you get an OH. The problem, though, if we oxidize, this won't get oxidized, but this would, and you turn it into the carboxylic acid. And then here you would have to eliminate. I'm trying to think if you had acid. No, it would cyclize probably. 1, 2, 3, 4, 5. Yeah, this is also going. So I was thinking again, eliminate and hydrogenate. But if you put acid in this, notice I have a carboxylic acid and alcohol. We saw yesterday that in order to do a Fischer esterification, right, you need an acid and alcohol, and if it's on the same molecule, it can cyclize on itself. So there's a good chance that this would all cyclize on itself and not do what I wanted it to do. It would somehow have to get rid of this, and it's hard to do when you have a double bond on there already. Like if I eliminated and hydrogenated, I'd have 2 alkenes, and it would, yeah. Yeah, I mean, this was the only way I thought of the red route because of these issues. You're going to get a lot of the same functional groups, but it's good that you guys are thinking like this. Trying to think if there's another way to do that, to put on that type of a Grignard. I don't know, did anyone come up with something else? Something different? It's very good, Anna, though. Let's see what Ashley says. This one is really, it is really hard. That's kind of why I kind of did it, just to get you thinking about where stuff has to go, all of the reactions. Again, I have to have the carboxylic acid at the end. I got to put on 3 carbons. What a lot of people want to do, and some people might have done this, so that's why I kind of do this, because I want to show this. I'm going to erase a lot of this stuff so I have more room here. Just because if some people did this, which some people might have, I want to make sure that you understand why you can't do it. what a lot of people try to do is they try to take this as their Grignard, all right, MgBr, and they say, oh, I need 3 carbons, so I'll just add an aldehyde with the 3 carbons, 1, 2, 3, right? And I'll add this in there, and 1, 2, 3, 1, 2, 3, and I made my compound, right? I added the Grignard, 3 carbons, but what is wrong with this? Why can't I do that? If you want to go off mic, you can go off mic and tell me. So I can't make that compound like this. All right. The reason is because this carbon attacks this carbon. Can't do Grignard with carbonyl. No, it could. It could. When I do this reaction, remember, Grignards do add onto carbonyls. That's what they do. This is the compound I make. The alcohol, so if I count this carbon 1, the alcohol, it goes on carbon 1. A lot of people just like, oh, well, it attaches, and I'll just put the alcohol over here. You know, you can't do that. That's what a lot of people try to do. Try to just add it on there, and then they put the OH anywhere that they want to put it. All right, it's remember that this is where the OH is going. Wherever the carbon with the Grignard is going attaches to the carbon that has a carbonyl. All right, and now at this point, there's no way that I can walk this OH over to here. So that's why it's not. I can't just do this. I have to put each carbon on at a time. And if I tried to eliminate this, I would get a double bond here, right, at the more substituted position. So that's why in this case you have to put on each carbon individually, and then on the very last step, once you have the carboxylic acid, you can then go ahead and make your ester. Okay? All right, so what you guys should do is either after class, which we're pretty much done, or later, like this evening or tomorrow, do this problem over again, all right? And try to do it by yourself with everything that we talked about. Andrea, at the start, when you're deciding how to even start, how did you know it was an ether instead of... No, it's an ester. It's not an ether. This is an ester. If I said ether, I apologize. But it's an ester group. Did I say ester or ether? I thought I said ester because in order to make it, you have to do a Fischer esterification. So I look at this, and it's an ester, carbonyl, and then an oxygen.